In this video we're looking at how to calculate the area of three-dimensional shapes. First of all, what have we done so far? Well, so far we've looked at how to calculate the area of simple 2D shapes, such as a square, and a triangle, this trapezium, and even a circle. We've used our knowledge of these simple shapes to find the areas of more complicated shapes. So for instance, this one on the left, we've been able to see that this is just a rectangle and a triangle put together, and to figure out the area of that. The one on the right here is just two rectangles, and we're able to use that information to find the area of these more complicated shapes. Working with 3D shapes at first might seem difficult, but it's just the same as finding the area of those more complicated 2D shapes. First of all, we have to be able to get these 3D shapes into 2 dimensions. So I have a cube here, an incredibly poorly drawn cube, sorry, but it's a cube because all sides are the same, there's 6 sides, and let's try and flatten that out. So I'm going to move this a little bit over here, and I like starting with the base, so I'm going to represent the base. And to the base we have 4 sides really. We have the front and the back, and the left and right. So we can put those on, left and right, and again these are all meant to be the same size. Got that, and finally we have a top. And then we can use our knowledge of how to find the area of all these sides, all these shapes, to find out the total surface area for a cube. So really that's just, well, the area for a square is the length squared, and you've got 6 of those, so the area for a cube will equal 6 L squared, because I have 6 sides, I'll times it by 6. This is a rectangular prism, and the surface area for this can also be worked out if you just make it a 2-dimensional shape. Again, I like working with the base, so I have my base and some sides. Actually, I might make that the front and back. Let's make that one the front, some sides, and a top. The only difference now from the previous example is that the rectangle has different length sides, so you'll have to know those before you can do any calculations. So let's do a worked example with my incredibly, again, poorly drawn rectangle. If we make this side, let's make that 7 for the width there. The breadth can be 5, and we'll go up by 6. Let's make it nice and easy. So I like starting with the base, which is this rectangle here. It's 7 by 5. Alright, that is my first value. 7 by 5, that equals 35. Alright, let's look at a side now. This is this one. And that is 6 times 5. That's going to equal 30. And finally, let's look at the face of the rectangle. And that's 6 by 7. And that's 42. If I add all those up together, I get 107. Now that's only for those 3 sides. That's only for the base, the side, and the face. But with rectangular prisms, you should know just by looking at it, if you had a real one, not a poorly drawn one like this, that the other sides are equal to exactly the same. So if you times 107 by 2, you'll get your final answer. And in this case, that would be 214. Okay, area and meters squared. So again, the way to solve this one is to find the area of 3 of the sides, the 3 different sides, and if you look back to if I just draw this quickly out as a net diagram, that can be 7 and that can be 5, that can be my base, and then I've got a 6 by 5 on the side. These are my sides. Okay, there are still 5. And then I have from the base, I have a face, which is 6. I have another repeating side unit. Sorry, not a side unit. If I go from the base to the front, now I'm at the top, which is another 5 by 7, because this is this top thing, 7 by 5, and then again I have the 6 by 7, which is the back of the shape. So all I've done here, 7 by 5 is this one, 6 by 5 is this, and 7 by 6 is this one. So it's these three. The other three shapes are exactly the same, so I can times by 2 to get 214 meters squared. Triangular prisms are a little bit more difficult. Instead of having 3 sides that are duplicated, you're going to have varying sides, as up to 5 different sides maybe. So the net diagram for this, again I'm going to start with the base, is going to be a rectangle. And then from the base we have the face, which is a triangle, and we also have the back, which is a triangle. And I'm going to call this large rectangle the roof. So that's my roof. And the remaining side is the side. I'm going to call it the side. So I have base, side, and roof. Again, let's do a worked example with this. So I'm going to make this 4, I'm not going to make it tricky on myself, 4 and 5 and 8. That's all the information we need to be able to solve this. So I'm going to start at the base. The base rectangle is 5 times 8. It's going to equal 40. Again, I haven't put units on my 40 meters squared. Let's go to the roof. The roof being this large one. And that there, actually I do need another value. I need to put another value in for this length. And let's make that 6. So it's going to be 6 by 8. It's going to equal 42. Let's look at the side, which is 4 by 8. That equals 30. What does that equal? 36. I'm doing poorly tonight. 32. See, even I can make mistakes. So I have the sides, and now I have the triangle. Now if you remember the area for a triangle, it is a half times the base times the height. And I have 2 triangles here. I have the front and the back. So in total I'm going to have 2 times a half times the base times height. Now I can do some cancelling here. 2 times a half is 1 times base times height. And that's just going to equal base times height. So base times height for my triangle, 4 by 5. 4 times 5, that equals 20. And I'm ready to add them all up, and I'll get my total area, which is 4 and 8, 10, 13. So again, I used my net diagram from the previous slide to be able to calculate this. I started with the base, which is 5 times 8. I then worked the roof, which is 6 by 8. I then did the side, which is 4 by 8. And then I did the 2 triangles using my modified formula. 2 triangles, so I found out the area for one, times it by 2 to get the total. And finally, this is an isosceles triangle prism. I know that because 2 sides of the triangle are the same, and much the same thing happens with this one, but it's actually a little bit easier. So the net diagram for this one looks like a base with 2 triangles on it and 2 equal sides coming off. Let's go through why that is. So I'm going to put some values in here. Let's say 10, 8, and 13. I'm going to make this one difficult for myself. And the height of my triangle is going to be 6. Let's put those values on our diagram. So here I'm going to have 13 for my base and 10. My triangles are going to be 8. The sides of my prism are going to be 8 by 13, so that's going to be 8 there as well. These are all 8. And the long are 13. And I can just do, again, find the area for each of those shapes to find the total area. And that's going to look like this. I have my base, which is 13 by 10. I have 2 rectangles that are 13 by 8. And I have the triangles, 2 triangles that have the height of 6 and the base of 10. And because there's 2 of them, I don't have to worry about the half. I can just do base times height. That gives me 60. Altogether, added up, that equals 398. So that's our quick look at looking at how to calculate the surface area for rectangular prisms and triangular prisms. In the next video we'll go over how to figure out the surface area for a cylinder, like a can or a tube or something like that. If any of this hasn't made sense the first time, please go back and watch it again, and if not, then you can just leave a comment and I'll get back to you. Thanks.